Hey everyone, welcome to Singularity Computers Client Build 6. Now this system is going to be very different from the systems I've been building recently, and actually very different from anything that you've seen me build so far. I'm really excited about this build, as I always am. So recently I've built systems such as Nighthawk and Singularity Beast 2, which are extremely high-end water-cooled builds. This system is actually going to have some mid-range components. It's going to be a compact LAN gaming build, and I'm going to pack in pretty much the most extreme water cooling system that I can fit into this case. This is the Bitfenix Prodigy, so it's a mini ITX case, which means I really don't have much space to work with. But the reason I'm going so far with the water cooling system is because I'm going to overclock the components to the max. I'm going to push them as far as they will go. For its size, the hardware and water cooling components that the Bitfenix Prodigy can fit is really just amazing, but I'm going to take that even further. I'm planning some substantial modifications of the case. Most of the modifications I'm going to do are performance related, but I'm also going to do a couple for aesthetics. Now I just thought I'd clear this up because I've had a lot of newcomers recently. This is certainly not the 6th client build I've done. I've been building systems for over 10 years, professionally for around 6 years. And I was thinking, you know, in the scheme of things, I've only ran my channel for a bit over a year. So really, you guys haven't seen many of my builds yet at all. There is so much more to come on my channel. Okay, now for a look at the components I'm going to use in the build. So I'm going to use the Asus P8Z77i Deluxe motherboard. For the boot drive, I'm going to use the OCZ Vertex 4 128GB SSD. The CPU is going to be the Intel Core i5 3570K, and as I mentioned, I'm going to overclock it to the maximum. You can see some Alphacool components there, which will be to mount my pump and reservoir configuration. For coolant, I'm using Mayhem's Pastel Ice White with Mayhem's Blue and Mayhem's Clear UV Blue dye. So I'm going for a UV effect. I'm going to have all UV lighting. Now the radiators that I'm going to use in the build is two Black Ice GTS, a 280mm and a 240mm. Now you might be thinking, why am I using a 280mm radiator in the Bitfenix Prodigy, and how am I going to do that? Well, you can see a clue as to how I'm going to achieve this, and as I mentioned, I am planning some substantial modifications to the case. So the case, as I mentioned, is the Bitfenix Prodigy, and it's the white edition. So my pump and reservoir configuration is a Swiftech MCP35X and an EK DDC X-Res 140. The water blocks are both EK CSQ nickel plexi. I have the EK Supremacy and also a water block for the AMD 7870. The lighting that I have here, I'm going to have to change to UV because I have two Bitfenix Alchemy LED strips. I also have a UNZ2 bracket, which is to mount my pump and reservoir configuration to one of my radiators. I'm going to use an 8GB kit of Corsair Vengeance DDR3. You can see this matches my color scheme. The graphics card will be an AMD Sapphire 7870. This is the gigahertz edition. The fans are all NoiseBlocker Black Silent Pro. I have two PK2s, which are 140mm fans, and three PLPS, which are 120mm fans. One of the PLPS will be for a case fan. Now, not all of the components have arrived yet. I'm still waiting on the power supply, a storage drive, the fittings, and a few other bits and pieces. When those components arrive, I'll cover them in detail. I'm looking forward to getting stuck into this build. It's now time for a more detailed look at all of the components. Okay, first up a look at the Asus P8Z77i Deluxe. Now, I've already done a review on this motherboard, and components that I've already reviewed, I only take a quick look at in my build logs. If you want all of the details, you need to check out the review. Now this is an incredible ITX motherboard. It's socket 1155Z77. You can see that the power delivery components are on a separate PCB, and this motherboard actually has a 10-phase digital power design, so that's going to allow for some substantial overclocking. 8-pin EPS CPU power connector. It can take up to 16 gigabytes of dual channel DDR3 up to 2400 megahertz overclocked. Full time 16 PCI Express 3 slot. I love the layout of this motherboard. The CPU socket is in the middle and most of the connectors are out around the outside. This motherboard has plenty of connectivity. You can see HDMI, DisplayPort, DVI, 4 USB 3 on the back I/O panel, 2 on the mid board. Also eSATA and 7.1 surround sound, plenty of USB 2. So this is an amazing little fully featured motherboard and I'm looking forward to seeing what it can do. I'm definitely going to push it to its limits. Next up, the Bitfenix Prodigy. Now, I've already done a review on this case also, so click on the link on the screen if you want all of the details. You're also going to get a very good look at this case during this build log because, as I mentioned, I'm planning some substantial modifications to the case. Now, the case doesn't look like what it's supposed to by default because I've already removed the hard drive cages and the 5.25 inch bay. But I'll just go over the basic specifications. So it has a single 5.25 inch bay, 5 3.5 inch, 9 2.5 inch, a couple of expansion slots. The motherboard mounts horizontally, the power supply mounts underneath it. Now, this case actually has water cooling capabilities. You can fit a 240mm radiator in the roof and in the front of the case. And it's also excellent for air cooling because you can fit up to 5 fans and there's a whole lot of different mounting options. So this is an excellent little compact case that can fit an incredible amount of hardware. Perfect for a compact LAN build or HTPC or anyone who wants a massive amount of performance in a small form factor. Okay, you're going to get a good look at these components as I'm installing them and also once they're installed, but I will give you a quick look at them anyway. Now, most of you will have seen plenty of this memory by now. This is an 8GB kit of dual channel Corsair Vengeance DDR3. It runs at 99924 1.5 volts. Now, the only reason that I chose the high profile version was purely for aesthetics. Otherwise, I would have just gone for the low profile version because memory modules run cool enough anyway. So you don't need to worry about going for high profile heat spreaders or water cooling or anything like that. It's not really going to make any difference unless you're planning on doing some extreme memory overclocking. Okay, the OCZ Vertex 4 128GB SSD. This is actually the first time I've laid hands on the Vertex 4, so I'm definitely going to do some testing. There will be test results towards the end of the build log, and I might also do a separate review on this SSD. Now, I'm not too sure about the aesthetics of these Alphacool 50mm reservoir mounts. I'll see how they look once they're installed. If they look okay, I'll stick with them, otherwise I'll swap them out. Now, the UN Z2 bracket. These are incredibly handy for a whole bunch of different applications. I use these in almost all of my builds. They are great for mounting reservoirs and pumps because the mount is 120mm square, so you can use it on a 120mm rad or 120mm fan, and really you can mount anything with them. Now for a look at the graphics card. So this is the AMD Sapphire 7870 GHz edition. Now I'm only going to give you a quick look because coming up I'm going to do a review on this graphics card, and at the same time I'm actually going to review the 7970, 7870 and 7770. But basically this graphics card has all of the features of the 7000 series. It has a 28nm GPU, 2GB of GDDR5. You can see it has a fairly high performance cooler from Sapphire with 2 80mm fans, a large fin array underneath, and you know, it's a fairly aesthetically pleasing cooler. Blue PCB though doesn't really match, but it actually does match the color scheme of my build, so that works out fairly well. So you can see it has some large copper heat pipes. Just a quick look around the back of the graphics card. It has 2 6-pin PCIe power connectors, and a look at the back I/O panel. So 2 mini DisplayPort, HDMI and DVI. And finally, a quick look around the back of the PCB. Next up, a look at the NoiseBlocker Black Silent Pro fans. So first of all, I'm going to take a look at the PK2. This is a 140mm fan. 54.7 CFM, 22.4 decibels, and 1200 RPM. It's a 3-pin fan. It has a static pressure of 1.27 millimeters H2O. Both of these fans have a 6-year warranty. They are premium fans. Now for a look at the PLPS. This is a 120 millimeter PWM fan from 600 to 1500 RPM. It has a static pressure of 1.833 millimeters H2O maximum, 23.5 to 58.86 CFM, and 8 to 24 decibels. Now for a look at the fans themselves. Now I use these fans in a lot of my builds, and it's because of the subtle and elegant aesthetics. I really like the aesthetics of these fans. You can see the blades are gloss and they're actually smoked. It's a real dark smoke. You can just see through them in normal light, but if you have lighting in your build, it will shine through the blades and it looks awesome. The frames are just a matte black. They have extremely short cables so that you can use whatever size extension cable you want to with the fans. Now towards the end of the build log, I will have noise output results, and you can also check out the temperature results for the water cooling system to see how well these fans perform. Next up, a look at the water blocks. So I have here two EK-CSQ nickel plexi blocks, the EK Supremacy and the EK FC7870. Now I recently did a review on the EK Supremacy. Click on the link on the screen if you want to check that out. So the water blocks match up nicely. You can see that both of the surfaces are frosted, which is going to look awesome in combination with lighting. Now the new EK-CSQ design has been a bit controversial. There's a number of people out there who are not that keen on it. It's taken a fair while to grow on me, but I actually really like it now. Now that I've seen it in a number of builds with different coolant colors and lighting, I thought it was going to be a bit of an eyesore, but really it just blends in and you don't even notice the new design. So just a quick look at the EK Supremacy. It's awesome that they've managed to improve on the EK Supreme HF, because that was an amazing water block. So a 20% increase in flow, 2-degree decrease in temperatures. Overall, I think this is an excellent water block and I gave it a positive review. There will be temperature results for this water block towards the end of the build log. Okay, now for a look at the EKFC7870. Now this is actually the first time I've laid hands on a CSQ graphics card water block, and I must say I actually really like it. I think the CSQ design really works with graphics card water blocks. I guess it's because there's more surface area, so you get to see more of it, and also because the top ends up being bigger than it needs to be, which I really like, because it means that the water block is bigger, it covers more of the graphics card PCB, and PCB is ugly. The less of it you can see, the better. Now I definitely love the frosting on this water block. I think it just goes perfectly with the design. And I like that you can see the base of the water block through the plexi top, because the base has a lot of shape to it. Now just a quick look under the base of the block. So you can see the contact points for the GPU memory and also power delivery components on the right hand side. Also the large cutouts. I think these really add to the aesthetics of the water block. There's a lot of cutouts in the plexi top also. Now most of this would just be to clear components on the PCB, but I definitely think it improves the look of the water block. So overall, definitely a great looking water block in my opinion. Now one thing that really bothers me about the new EK-CSQ graphics card water blocks is the EK-FC Link system. Whether you're using a single graphics card or multiple graphics cards, it's going to be highly restrictive. With the older EK graphics card water blocks, the inlet and outlet was on the top and bottom of the water block. You had complete freedom and you could use whatever fittings with it that you wanted. You can see that the FC link fits onto the bottom of the water block. There's just a single bolt that holds it into position. There's actually a lip on top to stop it from twisting. There's also two included O-rings which you need to place underneath the FC link. Now, when running a single graphics card with a CSQ graphics card water block and the EKFC Link system installed, the inlet and outlet is on the side of the water block. Without it, the inlet and outlet is on the bottom of the water block. Now, in a lot of systems, this is not going to matter, but in some systems, it's going to cause problems. And I'll show you later in the build log why it could cause problems in this build. Now, with multiple graphics card water cooling configurations, EK is pretty much forcing you to use the FC bridge. If you don't, and you use fittings such as BitsPower Crystal Link, you're going to be stuck using 90-degree fittings, so it's going to look big, bulky, and ugly. Now, EK has made improvements to the FC bridge. It follows through with the CSQ design. So if you don't mind using the FC bridge, I mean, there is benefits. You're matching up all of your water blocks. There's a plexi clear version. So just imagine, it's frosted. It looks awesome. If you matched it up with all of your plexi water blocks, the aesthetics could really be amazing. But if you want complete freedom and you want to use other multiple graphics card water cooling fittings, then it's going to be a problem. Okay, my reservoir and pump configuration. So I'm using the EK DDC XRES 140 and the Swiftech MCP35X. Now the XRES 140 comes with a number of different components which screw together, as you can see. The reservoir tube, which is 50 millimeters in diameter, so this is a bit of a smaller res than I normally use. I normally use 60 millimeter reservoir tubes. And it comes with the top cap and then this bottom piece which connects the tube to the pump top. Now, this pump top is made from acetyl. It can actually only be used with this configuration because it has a large thread in the top. There's a single inlet and outlet. The inlet is in the res, outlet is in the front of the pump top. Basically, this is a high quality, compact reservoir and pump top configuration with great aesthetics that is really easy to install. Okay, the Swiftech MCP35X, I'll just go over the basic specifications. It can handle 4.4 meters of head, puts out 22 psi and 17.5 liters per hour. This is an excellent little pump. It's powerful, it's almost completely inaudible. I use either this pump or the 655 these days in my builds, and I can tell you I'm really impressed with this pump. It almost stands up to the 655, although the 655 puts out 50 psi. But I've seen these little pumps in builds with massive amounts of water blocks, multiple radiators, basically way too many components, and the performance is still excellent. It's a PWM pump, so you can actually connect it to your motherboard and use fan profiles to control the speed of the pump. So great, powerful, compact little configuration for this build. So I mentioned that I'm going to use a 280mm and a 240mm radiator in the build. At this point in time, I'm planning on using Black Ice GT Gen 2 Stealths. I use these quite often in my builds. They're an excellent radiator. You're often faced with a situation where you need a thinner radiator, and these radiators are 29.6mm thick. The problem with using thinner radiators is that compared to something like a 60mm thick radiator, it's a substantial performance drop. But this radiator makes up for that because it has an extremely high FPI at 30 FPI. Now, you might be thinking that at 30 FPI it's going to be a loud configuration because you need high RPM, CFM and static pressure fans to push any air through that fin array. But that is actually not the case. If you take a look at the gaps between these fins, the gaps actually look similar to what you'd see in a 20 FPI radiator, or a radiator with even less FPI than that. And the way that Black Ice has achieved this, normally fins are 45 micron. The fins in this radiator are 25 micron. They're a lot thinner. Now, not only does thinner fins mean higher airflow, it also potentially means higher thermal conductivity, because the thinner the fins to a certain extent, the quicker they are going to cool down as the air passes through them. Black Ice radiators are also extremely high quality. I hardly ever see bent over fins on these radiators. Nice gloss black paint job. You can see that the end tanks are really small. M4 threads for mounting, G1 1/4 inch threads for the inlet and outlet, and there's actually plates under the mounting holes to protect the radiator from being pierced if you use bolts that are too long. So definitely an excellent radiator to use in a tight spot. So that's an overview of all of the components that have arrived so far that I'm going to use in the build. I'll start the next part of the build log by taking a look at the rest of the components. I'll then move on to modding the case because I have a lot of work to do on the case. That sums up this video. Thanks for watching. Please subscribe, like and favorite if you want to see more.